Here we go. Number 6. So we're going to use the same ideas we were doing before. We're going to clean this up, and we're going to do it by saying, we're going to say, what happens in this direction, independent what happens in this direction. That's what we just discussed. Independent. We just said, look, up, down, and left to right work independently of each other. Right? So we're going to go in the y direction. I have 1/2 at squared plus v naught t. And in the x direction, I have 1/2 at squared plus v naught t. In the x direction, I have 1/2. Now the first trick, the first thing that people struggle with, technically it's Mr. Cornell's chance to answer this question. So what's the acceleration in the x direction?
The x direction?
Yes.
0.
0. There's none. There's nothing making it go faster or slower once it leaves the barrel, right? It's gone. So there's nothing slowing down, speeding up, as long as we neglect air resistance, right? So, therefore, there's a big 0 here. How much time is it flying through the air?
2.02.
We technically don't know yet, but we'll find out in a moment. It's 2.02. What's my initial velocity?
300.
In the x direction? 300 meters per second. How much time? We don't know. So we got x equals 300 time. How much time it takes to do what? Hit the ground. How long does it take to hit the ground? Same as if I just dropped it. So I'm going to go ahead and go y equals 1/2. What's my acceleration? Oh, I messed that up already. My bad. How far is it going to go?
-20.
-20. Well done. Equals 1/2. What's my acceleration?
-9.8.
-9.8. How much time is in the air? Don't know. What's my initial velocity in the y direction?
0.
0. Not throwing it up or down. Times time. Solve that out. I then get -4 equals -9.8 t squared. I get t is equal to 2.02 seconds. Anybody disagree with that? Because I'm trusting you all.
Yes.
Other than what you wrote on the board, the answer's right, but it's -40 is equal to -9.8.
Oh, yeah. I made a decimal point there. That's bad. Okay, thank you. 2.02. So then I take this and plug it in over here. And I get
606.
606 meters in the x direction. Now, the way the question is worded, I should probably then do a Pythagoras thing. It says how far from the barrel. That's terrible. I'm going to ask almost always from the base of the cliff. So rather than bring that up now, I'm just going to say, the question is badly worded. We're going to do it mostly from down here, okay? From the bottom of the cliff. Is that okay with everybody?
Yeah.
So 6.06 meters from the bottom of the cliff is where that ball would hit the ground. Make sense?
Yes.
Okay. Understand why in the Revolutionary War, cannons were always dragged to the top of mountains?
There you go for the it's like
Almost always dragged to the top of mountains. Even though you can't point a cannon down, because the ball would roll out back then. They didn't have any way to keep it in. They would always drag the things to the top of hills because
go farther.
you go farther. All right. I'm done with 6. So let's... Oh, by the way, trig students, and this is one with a calculus student has no idea what we're talking about. Trig students, what kind of equations are these?
Parametric.
Parametric.
Yeah.
Usually I teach parametric in physics, not so much in trig, but this year we're teaching it in trig because I got no physics.
Let's see. So. Oh, wait, but that's velocity outwards.
Yeah.
She should have been with -9.8.
That'd be 28 miles per hour. Wait a second. If you jump off a 225 meter tall building, you're going to hit the safety net going 14 meters per second?
No, that was sorry. I was talking about number 10.
Okay, got it.
That's not entirely correct if you want to include the horizontal.
Okay, let's do the first part. Walk me through this. Who wants me? Welcome. Walk me through the first part.
Okay. So she's going to fall 225 meters. Yeah, 2 squared and plus 0.
So the time it takes to fall would be what?
Time to fall will be 6.78 seconds.
6.78 seconds. Let me disagree with that. Okay, next part. X equals 1/2. What's the acceleration in the x direction? Oh, wait, we know she wants to go 94.7. 1/2. What's the acceleration in the x direction?
0.
0. T squared. Plus what's my initial velocity in the x direction?
That's what you're solving.
What we're looking for, right?
Yeah.
How much time did she have before she hits the ground?
6.7.
6.78 seconds. Okay. Move that across. You get 94.7 equals 6.78 V naught. V naught has to be
Yeah.
what'd you get? 14.0 meters per second. Okay, so 14.0 meters per second. So again, she should not try this. Why? Usain Bolt would miss by about that much. Whoever this physics student is probably not going to run as fast as Usain Bolt, so they're going to land a distance shorter correspondingly. So, all right, but let's assume she's got roller skates on or something, so she's got electric speed. If she pulls this off, what speed does she hit the net with? So now we know she's going to hit the net going which direction roughly? Mr. Welko,
No.
point in the direction roughly she'd hit the net going.
About 66.4 meters per second.
Okay, but which direction would she hit it?
Which direction? Down?
Roughly. Like straight down?
No, like at like an angle.
I like an angle. Okay, so let's make sure we got that angle figured out. Okay, so if I'm at an angle, that's interesting because that means I've got a component this way and a component down. Since we're keeping things separated, we're going to want to keep those separated, are we not?
Yes.
How fast is she going in this direction when she hits the net?
It's going 14 meters per second.
14 meters per second. And how fast is she going in this direction when she hits the net?
66.4 meters.
Okay, how did you get that? So I can
You do 6.78 seconds.
equals V naught plus AT.
Yeah.
Final velocity is what I'm looking for. Initial velocity in the y direction would be 0. Acceleration in the y direction? Love it. Negative 9.8. How much time? 6.78. So the velocity in that direction would be?
66.4. Negative 66.4.
So how fast is she actually traveling when she hits the net?
That's a little different.
A squared plus B squared equals C squared, right?
67.9 meters per second.
So I go 14 squared plus 66.4 squared square root, and that gives me 67.9
Yeah.
or 120 miles per hour. So she's got two problems. First, she's going to miss the net, and even if she hits the net, she's going to hit it going about 130 miles an hour. Better be a really well put together net, especially considering she's apparently laying on the ground. Not going to give her much room to stop. She should probably retake the class before she tries that. All right. Go ahead and keep going. I think we got Burnell the monkey wrench.
No one tried that.
Oh, nope, not the monkey wrench.
This is about
Baseball.
Okay, but